Welcome to our introduction to polymorphism in object-oriented programming. In this video, we'll uncover the concept of polymorphism and its pivotal role in creating flexible and dynamic software. We'll start by defining what polymorphism is and how it allows objects to be treated as instances of their parent class rather than their actual class. Next, we'll explore the importance of polymorphism in OOP, highlighting how it enhances code reusability and scalability. To make things clearer, we'll use a real-world analogy to illustrate how polymorphism works in practice. Ready to see how polymorphism can elevate your programming skills? Let's dive in. Polymorphism, derived from Greek words meaning many forms, refers to the ability of a single function, method, or object to behave in multiple ways depending on its context in object-oriented programming OOP. Its significance lies in encouraging flexibility in code, enabling a more dynamic and extensible design, and reducing redundancy while increasing reusability. By allowing different classes to be treated as instances of the same class through a common interface or method, polymorphism fosters a cleaner and more efficient coding structure that can easily adapt to new requirements or changes. Polymorphism plays a crucial role in object-oriented programming by providing several key benefits. First, it offers flexibility, allowing programs to process objects of different types through a unified interface, which simplifies code and enhances functionality. Second, it improves maintainability, as changes made in a base class automatically propagate to all derived classes, significantly reducing maintenance overhead. Finally, polymorphism promotes extensibility. New types can be added with minimal changes to existing code, making it easier to evolve and adapt software systems over time. These advantages contribute to cleaner, more organized, and more manageable code bases, ultimately enhancing the overall software development process. The concept of polymorphism can be likened to how people communicate in different languages. Just as individuals adjust their language based on the context responding appropriately in English, Spanish, or any other language, polymorphism allows objects in programming to behave differently depending on their specific type or context. Despite these variations in expression, the underlying goal of communication remains consistent. Similarly, polymorphism in programming enables a unified interface for interacting with different object types while allowing each to respond in its own unique way, ultimately achieving a common objective. This analogy highlights the flexibility and adaptability that polymorphism brings to software design, much like effective communication in diverse linguistic environments. As we conclude our introduction to polymorphism, we've unlocked a powerful concept that is central to object-oriented programming. We started by defining what polymorphism is, understanding how it allows objects to be treated as instances of their parent class rather than their actual class. We explored the importance of polymorphism in enhancing flexibility and scalability in your code, enabling methods to operate on objects of different classes through a common interface. Finally, we used a real-world analogy to illustrate how polymorphism works in practice, making the abstract concept more tangible. With these insights, you're now equipped to harness the power of polymorphism to create more adaptable and dynamic code. Embrace this concept to build systems that are both flexible and robust. Happy coding, and may your projects always benefit from the elegance and efficiency of polymorphism.